Welcome. We're going to talk about RxJS higher order mapping operators. In this session, we're going to answer a couple of questions. What are higher order mapping operators? When would we ever want to use one? What the heck is an inner observable? And what's the difference between map, switchMap, ContentMap, and MergeMap? My name's Deborah Kurata. I'm a software developer and a Pluralsight author, and here is me in one of my favorite places on the planet, and I'm sure hoping to be able to go back someday. We'll see how life moves on. With that, I'm ready to jump right in. Let's dive in. So, first order versus higher order mapping. First order mapping transforms each emitted value and emits the result. So something like this. We get an emitted value into X, we multiply it by 2, and we get out the result. Higher order mapping transforms each emitted item into another observable. So here we're taking an ID, so we're getting a stream with that's going to be providing us an ID, and we're transforming that using the HTTP GET to go retrieve more data, which is going to give us back another observable. So that's the key difference between first order and higher order mapping. Let's dive into that a little bit more, starting with mapping, which is first order. No, not that first order. So when we issue an HTTP GET request to get some data from a server, we might end up with something like this on the left, where we're getting a data property with our array of data. But what we really want is just the array of data. It makes it easier to bind to and to work with. So we can use a map for that. We're going to use an HTTP GET to get the data, and then just map the response we're getting, which is the data on the left there. And we only want the data properties values, which is our array. So simple enough. Another example of map, say we're using HTTP GET request to get one single product. We want to add a property to that product. So we can use map for that as well. We're getting the data with an HTTP GET, and then we're mapping our product into a copy of the product using the spread operator, and then adding the additional property. So we make a copy of it to ensure that our original product remains immutable. And then we use as product to ensure that what comes out of our stream is an observable of product. One last example of how to use a map. Here again, we have our product on the left that we've retrieved, and we want to map it to a string for display on the top of the page. So how do we do that? We can take our stream that contained our product, and we can pipe it through here a simple operation to convert it to a string using the ternary operator. But what if we have something like this? So here's our set of products, and the user wants this beautiful ring here, so they click on ring. And what we want to have happen is the detail information to display. So we have a stream set up. When the user clicks on ring, it emits the ID of that, so ID 5, for example. Then it goes and retrieves the data for the detail, because our list page only has general information, not all of the detailed data. Okay, so our first thought might be to do something with a map. So we're going to take our selected ID that's emitted into our stream, and we're going to map it into a product. Sounds right? So we could write code like this. So we're taking our selected product action $, which is getting us this 5, because that's the one the user picked, and we're going to map it into an HTTP GET to go ahead and get the data. But this doesn't work. Bummer. Okay, so why? Well, before we answer the why question, let's talk about some terminology. So here's that same code. I just kind of centered it on the page. Why doesn't this work? Well, one of the things that we need to understand first is the terminology around this. Now, the first time I read this in the documentation without actually seeing code, I was quite confused, because it said something like, when the inner observable emits, and you're like, what the heck is an inner observable? Well, when you're actually looking at the code, it becomes obvious, and then at least I felt kind of silly for not quite getting what an inner observable is. But this part on the outside of the pipe, that's the outer observable. The piece on the inside is the inner observable. And again, you look at this and you go, oh, that was so obvious. But it isn't if you're just reading documentation and it's talking about the inner observable, like you would know what it was. Anyway, so outer observable, inner observable, we're going to use these terms quite a bit for the next couple of minutes. So going back to why this doesn't work. As you know, if you've used anything with RxJS, in order to make a stream work, you have to subscribe to it. Otherwise, it just doesn't go. You try to issue an HTTP GET request without a subscribe, and it just won't go. And if you're like me, sometime at the beginning, you've probably done that, where you issue an HTTP request, it never works, and it's because you haven't subscribed to it. So here in this case, we're going to subscribe to product $, either with a subscribe statement or with an async pipe. Subscribing to product $, subscribes to what it's equal to here, this .product selected action. So it starts that stream as well, and we start receiving all of the selection actions. The user clicked on the ring, that's ID 5, we're going to get the 5. We're mapping that to this HTTP GET, and guess what we're not doing here? We are not subscribing to that inner observable, and this code is never going to run because we're not getting that data. That GET is never going to occur. The other interesting thing is if you're in the editor and you hover over product $, you'll see that its type is observable of product. And that's just not right. That's not something that you're going to want to deal with or try to unwrap yourself. So how do we deal with this? And the answer is higher order mapping operators. Yay. So let's talk about what those are. Higher order mapping operators are a family of operators that ends in map. What they do is they map each value from a source or that outer observable to a new inner observable. But one of the key attributes of higher order mapping operators is that they automatically subscribe and unsubscribe from your inner observable for you so that you don't have to worry about it or mess with it. They then emit their resulting values to the output observable, and you get the binding that you're expecting to have. So you might end up with code then that looks like this. So this is the same code that we looked at before, but now we have switchMap instead of map. Now, if you ever go to Stack Overflow and ask any question about RxJS, you will see that a huge portion of the answers always is use switchMap. But there are other higher order mapping operators than just switchMap, and we're going to talk for a moment about what those are and when you would want to use which one. But having a higher order mapping operator means that it's going to automatically subscribe and unsubscribe from this inner observable, and this code is actually going to work. The other thing is if you hover your mouse over the product $, there, you will see that it unwrapped it for you as well. So you're going to be getting back an observable of product, which is what you're going to want for your binding for your detail page. Okay, so 3 of the higher order mapping operators that we're going to cover in our session here is the MergeMap, also called FlatMap, ContentMap, and switchMap. Okay. So let's start with MergeMap. So here again, same code, we're using MergeMap. So what is this going to do? Well, when we subscribe to product $, it is going to take in that observable, or in this case, the product selected action observable. It's going to subscribe to that stream so it can get the emissions from that stream, and it's going to create an output stream that it's then going to associate with our product $. Okay, then when an item is emitted, what it's going to do is it's going to take that item and map it to this inner observable, which specifies the URL for our HTTP GET. Then it's going to subscribe to that inner observable, so that sends it off and executes it. Then the inner observable emissions are concatenated to that output stream, and it unsubscribes from that observable, and we end up with our product $, observable of product. When should we use MergeMap? Anytime we want to process items in parallel, because what happens with MergeMap is if the user picks one and then picks a different one, then picks a different one, it's going to execute those requests right away and process those items in parallel. Now, because it's processing them in parallel and because it's all async, you can't depend on the order of the returned results. Some examples of when to use MergeMap: say you have a set of IDs and you want to get all of the suppliers for a product when order doesn't matter. It can send off the request for all of them all at the same time and get all of their values back. The next one we want to talk about then is ContentMap. ContentMap starts just the same as MergeMap did. On the subscribe to the source stream, it takes in the observable stream, subscribes to that stream, and creates an output stream. But ContentMap, unlike MergeMap, when an item is emitted from the stream, it philosophically queues it. So the emitted item is queued up. Then when the item is processed off the queue, at that point, the item is mapped to the inner observable. It subscribes to that inner observable. And another thing different about ContentMap than MergeMap is that it waits. So this code is going to just stop and wait till that response is returned. Then it's going to concatenate it to the output stream and unsubscribe. Only then does it take the next one off the queue. So it's going to be processing them one at a time, which is really good if you want to ensure that these are going to happen in sequence. So you want to use ContentMap anytime you actually want to wait for one to finish before starting the next one, the next inner observable. It will process those items in sequence. So a couple of examples on this one: from a set of IDs, get data in sequence, or from a set of IDs, update data. You really want to use consider using ContentMap if you're doing any kinds of updates, inserts, or deletes. Because you might want them actually in order. Say a user updates a product and then updates that same product a second time, you want to ensure that they are both processed in the order that the user made the updates. And ContentMap will help you ensure that happens. All right, the last one we want to talk about then is switchMap. Again, the exact same code, only now we have switchMap here. And just like the other higher order mapping operators, it starts the same. Unsubscribe to the source stream. So when we subscribe to product $, it subscribes to the product selected action. It takes in that observable stream, that product selected action stream, subscribes to it, and creates an output stream. So that process is the same for all of these operators. When an item is emitted from the source stream with switchMap, the item is mapped to the inner observable, but then what's different from switchMap than the other two is it unsubscribes from any prior inner observable. It then subscribes to the new inner observable, it concatenates its emission, and unsubscribes. So if the user picked 5, what it's going to do is start to get 4, then it's going to see that 5 was emitted, it's going to throw away the 4 and the subscription for that and go ahead and process the last selection that the user made, the one with ID of 5. Okay, so when would we use switchMap? To stop any prior observable before switching to the next one, to process basically the most recent item. For example, type ahead. So if the user types 2 letters, you might go off and start searching for something. As soon as they type the 3rd, you really don't care about the results from the first 2 characters. Now you want the results for the 3. Another example is user selection from a list, because if they could pick multiple ones and you only want ever their last selection to be processed, you want to use a switchMap. Okay, so our higher order mapping operators are MergeMap, which executes inner observables in parallel; ContentMap, which waits for each inner observable to complete; and switchMap, which unsubscribes from the prior observable before switching to the new one. Okay, so now it's time for a quiz. We're going to try out the polling features here. And hopefully this is going to work. You should see a polling button on the bottom of your screen, kind of near the Ask a Question. And we're going to have the first question of our quiz come up here momentarily. So this first quiz question is on quick selection. So we've got our list of products on the left, and when the user picks one, we're going to display the detail on the right. But the user could do, oh, I want saw. No, leaf rake, no, hammer. So they quickly picked 3 different ones. Only you, of course, only want to display their last one. So on the quiz, define whether you think that the best operator to use in this case would be a map, MergeMap, concat-map, or switchMap. All right, so while you're doing that, I'm going to go through each one. So here is the code. Again, that's kind of the same code we've been looking at, and we're going to figure out what mapping operator makes the most sense in this particular case. If we went with a MergeMap, what would happen is it would start executing all of these in parallel. And it's possible if leaf rake required a little extra time, maybe it has more detailed data associated with it, it could actually be returned last. You could end up receiving 1, 3, and 2. And what would happen then in this case is on the left, the user would look like they picked hammer, but the data on the right would be the leaf rake. And then, you get a call from a user and you try to repeat it, and, you don't have that same lag for your machine and you don't see it. So it could really cause some hard to find and hard to debug issues. So you want to be careful using MergeMap for these kinds of scenarios. All right, concat-map. What this would do is it would get the first one, wait till you got it, depending upon how slow the network is, maybe even display it, then get the second one, display that one, then get the third one and display that one. So the nice thing about concat-map over MergeMap is that you would at least end up with always the last one that they picked because they are processed in sequence. But it might take a long time to get there depending upon how much that they clicked around and the speed of the connection. What about switchMap? Well, what will happen with switchMap is when the user clicks saw, it will go try to get saw. The user clicks on leaf rake, it's going to cancel the first request and go try to get a leaf rake. Then it's going to cancel that request when the user clicks on hammer, and it's going to end up just really returning the 1. So in this case, switchMap was the answer. So switchMap. So I hope you got that right. All right, so second quiz, just to show that every answer isn't always switchMap, like Stack Overflow sometimes might lead you to believe. We're going to look at another example, and this is related data. So we've got a second quiz for this one, but let me talk through the scenario here. So in this case, the user is still picking an item from the left. It's showing the detail on the right. But now, in addition to the detail for the hammer, we're getting the IDs of the suppliers, and we need to take those IDs and go retrieve the supplier detail, because the user doesn't want to see, oh, it's supplier 52 and 64. They want to actually see the supplier name data. So the code might look something like this. So we're going to use from to ensure that's an observable. We're going to take our supplier IDs and pipe them through some operator. And for each supplier ID that we're processing, we're going to go get the supplier. At the end, we're putting them into an array. Why are we putting them into an array? Because we want to bind to them on the bottom as a single array, not one showing up at a time. ToArray will wait for the outer observable to complete before it will actually emit its result. Okay, so check out the poll and see which operator you think would be correct here. Map, MergeMap, concat-map, switchMap. All right, so what if we used MergeMap? Well, MergeMap will go get them all at the same time. So if I had 10 of them, it's going to go issue 10 requests and get all of those back in who knows what order. If we don't care about order, we're going to very quickly get back all the data we need, complete, and our ToArray will let us bind to the result, and we'll see our set of suppliers. All right, what about concat-map? Well, what that's going to do is get the first one, wait for it to finish, then get the next one, wait for it to finish. And if you had 10 of these, it would be doing them one at a time, waiting for the first one to finish before getting the next one. Now, the nice thing about that is it will retain order. So if you needed these in a particular order for some reason, then ContentMap might be a good option. But otherwise, it could take, if you had 10 of them, it could take literally 10 times longer than the MergeMap to get the data. Okay, what about switchMap? What would happen in this case? Well, it would process the first one, get emitted the second one, so cancel that first one, go to get the second one, see the third one, cancel, and so on, and you'll end up with just one. And I have a little UI oops there, but basically you would only get one at the end with your array, that last one in the list, which isn't at all what you want. So hopefully what your answer was a MergeMap in this case, if you don't care about order. Otherwise, a ContentMap might be your best option. All right, you can find my slides at this link. You can find sample code on my GitHub. I also created a stack list that you can play around with that demonstrates some of these things. And with that, I want to thank you all very much. Stay safe.